Okay, this is section 4.7, part 1, and we're going to talk about inverse trig functions. And the good thing is we've actually done a little bit of this. So as far as the math, it won't be real new. But let's talk first about what an inverse function is. Okay, the first thing, for a function to have an inverse, it must be 1-to-1. So that means that it must pass the horizontal line test. So I have the graph of y equals sine x here, and it looks like I'm going, from negative 3 pi to 3 pi. And if you see, if I draw, horizontal lines, like a horizontal line right here, I pass more than one point at a time. So for it to be a 1-to-1 function, when I draw a horizontal line, it cannot pass more than one point at a time. So sine x does not pass that rule. Okay, so if I look at just a certain part of the sine graph, okay, so let's look at just the part from negative pi over 2. Okay, so I don't know, on this one it'd be somewhere around here, to positive pi over 2, somewhere around here. Okay, well, I have that part of the sine graph right here. So the following properties are true for just that part. The function y equals sine x is increasing because it's rising the whole time. Sine x takes on its full range of values, so I still go from negative 1 to 1. And my sine x is a 1-to-1 function now, okay, because it passes that horizontal line test. So if we look at our notes, on the restricted domain from negative pi over 2 to positive pi over 2, y equals sine x has a unique inverse called the inverse sine function. And here's how it is denoted. There's two different ways you can write the inverse function. Here's one way, y equals arc sine of x. So anytime you see the word arc in front of your sine, cosine, or tangent, they're talking about the inverse of those functions. Another way we could write it is this right here, y equals sine to the negative 1x. Okay, usually when we see this, if I had 2 to the negative 1, I could rewrite it as 1 over 2. In this case, that does not mean that I can put 1 over sine x. Okay, this is the symbol for the inverse of sine, which is different than 1 over sine. Okay, and we'll talk about that here in a minute. So let's look at the definition of inverse sine function. The inverse sine function is defined by y equals arc sine x if and only if sine y equals x. Okay, where our x's between negative 1 and 1, and our y's are between negative pi over 2 and pi over 2. And if you remember, the reason those are different is because when we have inverses, we switch our x's and y's. Okay, and the domain of arc sine is negative 1 to 1, and the range goes from negative pi over 2 to pi over 2. Okay, now here's how we're going to use that information. And if you look, here's y. Okay, went from negative pi over 2 to pi over 2. My y values are negative 1 to 1. And so whenever I do the inverse, I switch those x's and y's. Now here's how we're going to use that. Okay, when evaluating the inverse sine function, it helps to remember the phrase, the arc sine of x is the angle whose sine is x. So when we're finding inverse trig functions, we are looking for the angle that whatever happens. Okay, whatever number they're talking about, we want to find the angle at which that happens. So let's look at example 1. If possible, find the exact value. So remember, arc sine, or this right here, means I'm looking for an angle. Okay, well, first of all, we're going to be drawing a triangle. And we have to figure out which quadrant I would be drawing my triangle. Well, this says that arc sine is negative 1/2. So I know that sine is negative. Well, remember, all students take calculus. So I know sine is negative in this quadrant right here and this quadrant right here. But here's the deal. When we do these, we have to narrow it down based on, okay, our range. So our range for sine, and I'm going to write this, is it goes from negative pi over 2 to positive pi over 2. So when we do these problems for this section, we can only have our answer that's inside the range that they gave us. So negative pi over 2 to pi over 2, do you see that this right here is negative pi over 2, and this right here is positive pi over 2? So what they're saying is our answer has to fall between negative pi over 2 and positive pi over 2. It has to be in one of these two quadrants. So when I draw my triangle for sine and it's negative, I can't draw it in the first quadrant because sine is positive there. That means I must have to draw it in this fourth quadrant. Okay, now here's my angle. We know that sine is y over hypotenuse or opposite over hypotenuse, however you want to look at it. So my y value, or my opposite side, is -1, my hypotenuse is 2. When I do the Pythagorean theorem, I get the square root of 3 as my other side. Now, my job is to figure out what type of triangle do I have. Well, I know, by looking at my sides, I have a 30-60 triangle. And then my job is to figure out what this angle is. Well, I always find my 1, because 1 is my shortest side, and my shortest side is always opposite my 30-degree angle. So I know that this angle right here has to be 30 degrees. Okay, now how can I name this angle so that it falls between negative pi over 2 and pi over 2? Or remember, negative 90 degrees to 90 degrees. Okay, well, if this is 30 degrees, can't I also name that as negative 30 degrees? And today we're going to put all of our answers in radian form. So 30 is negative pi over 6. So my answer for A is negative pi over 6. All right, so now that we've done the first one, these won't take near as long. So the inverse of sine is the square root of 3 over 2. I know for sine, I have to draw my triangles in either the first or fourth quadrant. Since sine is positive, I'm going to draw it in the first quadrant. Okay, here's my angle. I know that sine is opposite over hypotenuse, or y over my radius, or hypotenuse. So this is square root of 3 over 2. When I do the Pythagorean theorem to get my other side, this is 1. So I have a 30-60 triangle again. Okay, and I always find my 1. The side opposite my 1 is always 30. So if this is 30, that means this one must be 60. So on this one, it's 60 degrees. Can I leave it? Can I name it as 60? Yes, because 60 falls between negative 90 and 90. But we want our answers in radian form. So it's the square root of 3. I mean, it's square root of 3, pi over 3. Okay, now we're going to do C. Again, sine is positive. So normally I would be drawing my angle, or my angle in quadrant 1. Sine is y over r, so this would be 2 over 1. So my y is 2, my r is 1. Now, that's a problem, because can my hypotenuse ever be smaller than one of my legs in my right triangle? And it can't be. So I know that this is not possible, or does not exist. Now, if it were a point on my unit circle, that would be different, okay? But this can never happen, and I'll show you a point on your unit circle here in a minute. Okay, so we've talked about sine, so what about cosine and tangent? So cosine and tangent, okay, I could have showed you the entire graph, but I just showed you the part where they restricted the domain to make it a one-to-one function so that we can have an inverse. So for cosine, we had to restrict the domain from 0 to pi, okay? I could have continued this on out, and here's the rest of my cosine graph, but from 0 to pi, it makes it a one-to-one function. Okay, from tangent, for tangent they go from negative pi over 2 to pi over 2. Okay, so here's my graph of tangent from negative pi over 2 to pi over 2. So here are the main things that you need to remember for our definition of our inverse trig functions. Okay, and if you'll notice, I know this looks like a typo, but it really isn't. Y equals arc sine x. IFF stands for if and only if. Okay, so sine y equals x. My domain is from -1 to 1. My range for sine, -pi/2 to pi/2. For cosine, our answers have to fall between 0 and pi. And then for tangent, our answers have to fall between -pi/2 and +pi/2. Okay, so let's do some problems. Find the exact value for arc cosine square root of 2 over 2. So I'm going to draw my xy axis. I'm going to look up here for cosine. I know for cosine, I have to draw my triangle between these, either between 0 and pi/2. So it has to be in this first and second quadrants. Cosine is positive in this problem, so that means I must be drawing my angle in quadrant 1. Okay, now I know that cosine is x over r, or adjacent over hypotenuse. So my adjacent side is square root of 2. My hypotenuse is 2. When I use Pythagorean Theorem on this one, I get square root of 2 for my other side. So we have to figure out what kind of triangle we have. Since my two legs are the same, I must have a 45-45. So that means that this angle right here is 45 degrees. Okay, so can I leave it named as 45? Yes, because my answers have to go between 0 and pi, or 0 and 180. So 45 degrees is pi/4, and that's my answer. Okay, let's look at B. The inverse of cosine is -1. So remember, this is just another way to write arc cosine. So cosine is -1. Now this one's different. Okay. Can I draw a triangle that my adjacent side is -1 and my hypotenuse is +1? I can't. Okay. But this says on my unit circle where my x value is -1. Okay, so you see for cosine, cosine is my x value. That's my point right there. So for cosine, my answers have to be between 0 and pi. Well, what is this angle right here? Well, all the way around, this is pi. So my answer for B is pi. So remember what we're finding. They're saying our answer means the cosine of pi/4 is the square root of 2 over 2. The cosine of pi is -1. So now let's do arctangent. Arctangent is 0. So again, I can't draw a triangle with a 0 side. So first of all, let's look at where our answers for arctangent has to be. It has to be between -pi/2 and pi/2. Okay. So I either have to have a point here. Oh, and look at our range. It cannot be pi/2 or pi/2. It has to be between those. So the only way I can have that is this point right here. That's the point 1, 0. Remember, tangent is our y over our x. So is our y value 0? Yes. Is our x value 1? Yes. So what is this point right here? It is 0 degrees, 40 radians. So we're saying the tangent of 0 is 0. Okay, let's do this one. Okay, tangent -1, remember it has to be either in the fourth quadrant or the first quadrant. Everything's positive in the first, so it has to be over here in this fourth quadrant. Tangent is y over x. So that means my y value is -1, my x value is 1. When I use Pythagorean Theorem, okay, 1, that's going to be what? Square root of 2. So this must be a 45-45. So this angle right here is 45 degrees. Now here's the deal. Okay, I have to figure out a way to name this angle that names it between negative pi over 2 and positive pi over 2. Okay, this angle would be negative 45 degrees, or in radians, negative pi over 4. Okay, the last part of the examples just has you use your calculator to approximate the values of the angle that they're wanting to find. When putting this in your calculator, and I can't show you, but on my calculator I would hit my second button and then my tangent button. And when you hit that, you should show this on your calculator. And then you would enter in negative 8.45, and then it's going to give you whatever it's going to give you. Make sure you're in radian form. Okay, on this one, this is a typo. This should say sine to the negative 1 of 0.2447. So again, I'm going to hit second sine 0.2447 and see what you get. This would be second cosine of 2 and see what you get. Okay, so go ahead and plug those in. Now, if you get an error message, and sometimes you will, an error message means that that's not possible. There's no angle that's what it's going to equal. Okay, just like we did on C, for example, 1. The sine, the inverse sine of 2, it's not possible. Okay, so if you get an error message when doing it on your calculator, it doesn't mean that you've made a mistake. It just means that it's not possible. All right, that is it, and I'll answer any questions in class.